When approaching how to solve an absolute value inequality, it is most helpful to think about our compound statements, and or, because that is tied to the definition. If we know that the distance of some amount is less than a quantity, we know that it is between the negative and the positive of that value. That is essentially saying an and statement needs to be solved. So in examining the inequality, we notice this is greater than. Example 2 is less than. This tells us we will approach things differently. Example 2, less than, will be approached like the and statement we see. Following the model that the definition gives us, we can write an and statement as a shorthand. Negative 5 is less than 2x minus 1. Notice the absolute value bars have been removed, which is less than 5. I still prefer that it is then written as two separate parts to go forward with the solution. Writing the variable first, you'll notice that 2x minus 1 is greater than negative 5, while 2x minus 1 is less than positive 5. So you can go directly from this statement, creating the habit of saying, well, in case 1, we're going to have 2x minus 5 is less than 2x minus 1 is less than 5, the direct translation, and 2x minus 1 will be greater than the opposite direction. We move forward much like we did in part 1, solving each individual portion and then noting that the and true part is contained between negative 2 and 3. This time, because they're not included, we want to make evident open circles, and our sentence in set builder notation would be stated as a set of all x such that negative 2 is less than x, which is less than 3. Continuing then by returning to example 1, what we notice is that it has the greater than symbol as part of its inequality statement of absolute values. Notice that when the relationship is a greater than in the example, the rule then has a different outcome. It's related to the word or compound statements. So we will rewrite it then as the interior x plus 2 must be greater than 4. In other words, just like the original statement, but without the absolute value bars. And then our joining word is or, and it's x plus 2. Now notice, we now reverse the direction of the symbol and add the opposite. So we're going to say is less than negative 4. This is how we create our two statements to go forward with solving. In highlighting the x is greater than 2 in the purple, or x is less than negative 6, we notice that they extend in opposite directions, but because it's an or, we know that as long as the number is under one color or the other color, it is part of the solution set. We would write this then in set builder notation as a set of all x such that x is less than negative 6 or x is greater than 2. When using compound or, there is no shorthand way to write things in set builder notation like we found when the connecting compound word is and.